Hi you guys, today we're going to be solving quadratics using the square roots method. So we need to understand how to do this before we can actually graph our quadratics in vertex form. So our essential question, when do you use the square roots method? And these are actually the two forms that you guys will be seeing. So it's ax squared plus c equals b. Here you are actually missing the bx term. So that's the one that you know if we are using the square roots method, is if we are missing that term there. Okay. And then this other term here, this is actually your vertex form, which you'll be seeing in the next set of notes. So if we have our a in parentheses x times x minus h squared plus k, this also is when we will be using the vertex form, or sorry, the solving quadratics using square roots method. So our steps here, our first step, we're going to isolate the squared value. So meaning that if you look back at this form, I would be getting rid of the c term. So I would be adding or subtracting and getting and then getting that c over there, and then also dividing by if there's like a coefficient on the x squared, so that I have this x squared term by itself. Same thing with this term here. If I have a k value here, I would add or subtract it to bring it over to that side, and then I would divide, my next step I would divide that a value so that I have this by itself. So that's what I mean by isolating the squared value. So you would either get it so that it's by itself like this, the x squared, or you would also get the x minus h squared value by itself. So that's what you're trying to isolate. Then our second step, you're going to actually take the square root of both sides, so that's why we want to get that by itself, so then we can take the square root, eliminating those values there. Okay, so those are our two steps. Let's actually do some examples here. So now I'm going to have my x squared minus 49. My first step is to isolate the x squared value. So I have to add 49 to both sides, then get x squared equals 49. Okay, so now since I have that squared term by itself, my second step is to actually take the square root of both sides, canceling out the squareds. So now I have x equals, and since I added that square root to the equation, I now have a plus or a minus 7. So the square root of 49 is 7, so that means I actually have two solutions here, x equals 7 and x equals a negative 7. For our next example, we have a very similar example here, but it's a positive 49. So I'm going to subtract 49 from both sides, and I get an x squared equals a negative 49. So according to the fundamental theorem of algebra, it says that we should have two roots. So that doesn't specify if we should have two real roots or two imaginary roots. So what I want to show you here is I go through this process. I got my x squared by itself, square root both sides. This is x equals, however, I cannot take a square root of a negative number. So remember that we have the square root of negative 1 that actually becomes an imaginary number, an I. So now I have a plus or minus, and I would take the square root of a negative 1 times it by the square root of 49, because now I'm allowed to actually take the square root of 49, which is the plus or minus 7 still, and then this is the I. So our actual value would be plus or minus, and we always write the number as basically like a coefficient in front of our variable. So we do still have two roots, they just happen to be imaginary. We have a 7i, and then we also have a negative 7i. What this means is that this actually does not hit our it doesn't hit the actual x-axis. So it's just going to be kind of a floating graph on the actual graph. Next, this is our vertex form that you guys will be working with, like I said, in the next set of the notes. So this is how we solve for our vertex form of quadratics using the square roots method. You're always going to set your y equal to 0 so that we can actually work with a value. So we're going to have subtract 3. Again, we're trying to get this x squared by itself, and we actually did so by just subtracting 3. Then we're going to go ahead and take the square root of this value. Again, we realize that we cannot take a square root of that number here, so we actually have to leave it as the square root of negative 3, or we can write it as our I square root 3, and I'll show you guys this in a second. So again, we're going to add 2. Let's finish doing this. X equals and we're going to have our square, let's do 2 plus minus the square root of negative 3. So when I rewrite this, we're going to make this an I, root 3. So then we have our 2 plus root 3I, and we also have our 2 minus the root 3I. And the reason why that root 3 became positive is because I made the I, which is that square root negative 1. So again, by the fundamental theorem of algebra, our 2 tells us we have 2 roots, but in this case they happen to be imaginary again, which means that they won't be crossing the x-axis, that it will just be a floating graph that will not cross the x-axis. Let's look at our last example here. So again, we have our vertex form, which we are going to get our y equal to 0 first before we start solving anything. We're going to go ahead and divide by 3 first because that's that number, it's kind of like a coefficient in front of our variable. So then I'm left with my squared term, which is what we wanted to do. 0 divided by a number is always 0, and then we are going to square root now that we got that squared term by itself, and we get x minus 4 equals the square root of 0 is just 0. So the thing is that we can't have a plus and a minus 0. What we actually call this is a double root. Because the fundamental theorem of algebra tells us that we have two real roots, the reason why we have a double root is because we have technically a plus and a minus 1 right there. So, but again, can't have a plus or a minus 0, so we just have it as 0. So now we're just going to finish solving for x, and we won't be adding a plus or minus 0 to 4. So our value is just x equals 4. So this is where it will be crossing our x-axis, which means it's only going to be crossing it one time right there, which means that it's a double root because of that plus minus 0. Alright, you guys, that is it for our notes today. So go ahead and try and practice some of these the square roots method on your own. Hope you guys had a wonderful day.